Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh, ladies and gentlemen. Welcome back to another live stream. Alright, so another adventure, isn't it? Okay, cool. Now, I'm just going to share the link of the stream. Well, copy video URL. Let's go. Right. Stream is up. Everyone, okay. And let's go. Let's pop out the chat. And there you go. Cool. Alright, so we're gonna wait about 5 to 10 minutes for interested people to join in, if there's any. So yeah, we'll start our journey. Okay. All right. Oopsies, what I've done there. Okay. A pin message. All right, cool. Cool. So how much time is gone by? Around 2 minutes and a half. All right. Hello, Sang, Ruba, Yang, Pastinia or Pastinia? Vulkan sing it. Oh man, that's a long name. But welcome to the stream. Welcome. Alright. Just waiting a bit more for anyone that is interested to join in. Okay. Right around 3 minutes and a half have passed. Okay. While that's happening, I'd like to check out on maybe Zig standard documentation. There's a lot of interesting stuff there that I still didn't explore, and honestly it's been pretty great to see some interesting stuff. For example, like multi-array list. It's pretty useful for data-oriented what can I say, data-oriented design, I think. Anyway, there's also packed int. And yeah, so another one. So I wanted the fallback thing. Okay, hold on. Stack allocator or stack fallback. There you go. So this one particularly found it very interesting. Okay, an allocator that attempts to allocate using a fixed buffer allocator using an array of size. So I actually asked the question on Zig Discord. Oh yeah, let's go, Travis. Sounds to me like std.bounded array would be most similar to Rust smallvec. Basically matches the array list API, but with the fixed buffer size. All right. So I asked, is there such a thing in the Zig standard library? Otherwise, I have a function that may return one item or multiple items. What would be a conventional solution to avoid the allocation in case of having one object and allocate otherwise? Or what about something like smallvec in Rust? So there is a crate called smallvec in Rust. So if we look into Rust smallvec, so there's this interesting crate. So I'll just read out for you the description. It's pretty descriptive. Small vectors in various sizes. These store a certain number of elements in line, basically I think in the stack, and fall back to the heap for larger allocations. This can be used for optimization for improving cache locality and reducing allocator traffic for workloads that fit within the inline buffer. So yeah. There's also another crate which serves a similar thing, and also there's also Rust. Right. So cow, Rust cow, basically copy on write. This is also a very interesting thing that I actually never really used, never really thought about a case for it. But it's pretty interesting when I found out really what it means. And so a clone on write smart pointer. The type cow is a smart pointer providing clone on write functionality. It can unclose and provide immutable access to borrowed data and clone the data lazily when mutation or ownership is required. So I do not think that this description is very descriptive, but basically there's a very simple example that I've talked about here. So also, if someone doesn't know what a cow is, a simple example would be a function that takes a string and converts it into uppercase. The result should ideally be a cow string instead of a string. So if the given string is already all uppercase, no change, then we don't need to allocate a new string. We just return the string passed. Otherwise, of course, we allocate. So yeah, pretty much. Pretty cool stuff. I got that example from the Rust Discord. I asked that question a long time ago. So yeah. Okay, so I'm trying to find something like that in Zig, and so far I got one interesting answer, which is stack fallback allocator, which is very interesting, and also I wonder if Travis is on stream. Okay, let's see. Oh, by the way, I didn't actually... There you go, I just tuned in. Okay, let's go. Travis is on again. So, I should actually share the link in the Zig server. Streams, let's go. And let's go. So the streams tab in the Zig server is basically kind of like just a stripe between Christoph and me and Vulkan and Zig's thing, as you can see. Well, at least almost. So yeah, let's go. So I think, how much time I've passed by right now? 9 minutes. All right, so I think we will start now the actual adventure. Okay, pretty cool. Pretty cool. And also, I didn't actually check out. I checked out unbounded array, but I didn't really look into it more. Let me check it out though. Where can I find that? Zig bounded array. Well, zig docs std. Let's go. Bounded array. Oopsies. Structure with an array in the length that can be used as a slice. Useful to pass around small arrays whose exact size is only known at runtime, but whose maximum size is known at comp time, without requiring an allocator. This actually fits very well the description that I have about small vec. Sounds like you're wrangling with or without different FN return types. Oh yeah, I was trying to kind of generalize the iterator struct more, but I kind of failed there. I thought it was I underestimated it, but it seems like it's kind of hard in Zig, at least with my experience. So off camera I tried to do such a things. That's why I was actually asked the question about get function return type, how to get a function return type at comp time, of course. So you basically say type info, type of, you give it the function name, of course, .fn, .return type. And the best of the best, he gave me a link to where I can find more about it. Because I always struggle with Zig. Why? Because there is less documentation and I don't know exactly where to find everything. I like more information about everything, and this is basically a gold mine for me. Let's go. So if you go to the built-in.zig file in the GitHub of Zig repo, you could find this and basically have everything about it. So if we go to function, where is function? FN, right. Here, this is all the stuff that you can actually know at comp time about some certain function, which is honestly very, very powerful feature. So, okay, let's go back into the code, I think. Maybe you can pass the iterator a type. I actually tried to do a lot of crazy stuff there, but for now, I think it doesn't really worth it to waste time on it currently. But I'm thinking, oh, also, one another thing about the version though. I found another thing in the standard library called version. So maybe we could use that instead. There is a lot of interesting things in the standard library that I should actually explore, honestly. Maybe some stream later on, like to explore just the standard library and trying to understand more stuff about it. But yeah, so there is this type called the software version formatted according to the semantic version 2 specification, which have major minor patch. Isn't that familiar? So can we use that? Or maybe we do not. Let's see. Well, the thing is we need this guy. So I think it's fine, honestly. Currently we're not using version though. Version. Yeah, we're not using it. So I think let's just remove this guy. There's no need for it. I'm just going to use the Zig standard library semantic version there when I need it. Physical device type, I'm going to let that slide for now. Now the thing that I was thinking about is to do some minor optimizations here and there. For example, if we go to, well, where we're doing allocations though. Let's see where we're doing allocations. Yo, what? Oh. Okay, so first of all, we're doing it here, physical devices. Now, physical devices doesn't necessarily always have like more than one. In fact, a lot of times it would be just one physical device. Like most people just have one GPU, you know. So including me, I think. So this would be a very good idea to actually use that fallback allocator thing that we learned about. So we do not have to always allocate, because basically when you have one physical device, then why allocate a whole array in memory? And one other information is that small allocations is kind of bad. You know, it quickly fragments your memory. So yeah, like memory fragmentation is very bad for applications that would run for a long time. So yeah, okay, let's see how we can actually improve this. Hopefully I didn't do this before, so we're just going to find out now. So stock fallback allocator, an allocator that attempts to allocate using a fixed buffer allocator using an array of size. If the allocation fails, it will fall back to use. Now, what's the difference between this bounded array and the stack fallback allocator? Huh? What's the difference? Bounded array is basically a static array list. Yeah, it makes sense. I wonder what's the difference between a bounded array and a stack fallback allocator is an allocator. But why you would use like stack fallback allocator instead of a bounded array? I think I'm missing something here. So I guess maybe let's try to start with using bounded array then. I think. No, we cannot use it in this case, I guess. You know why? Because we do not have like a bound, like we do not know a hard limit of how much physical devices we're going to have. Yeah, we do not have max size in this case. Yeah, exactly. So we do not have max size in this case. I do not think the API tells us anything, that like the Vulkan API tells us anything about that there is a maximum amount of physical devices, at least as far as I know. So I think we're gonna go with stock fallback allocator then. Okay, let's try to figure out how this works. So stack fallback allocator, you give it a size. Easily created with stack fallback. Let's go. Stack fallback. So you give it some comp time size and then a fallback allocator. Well, that's interesting. That's very interesting. Okay. Well, how we're going to do this, I wonder. Let's see. Where is that physical device stuff? Hold on a second. Alloc. So it's right here. Okay. So I think, well, let's just see what we could do here. So std dot, where is that thing? It's in the heap. Stack fallback. Okay, you can make one like this. RSFA SFA std heap stack fallback 1024 allocator. Let's see. So stack fallback allocator. Let's see. No, not this. I wanted to use this guy. Maybe this guy. So you give it some size. Honestly, I think probably physical devices, you'd probably only have up to maybe 4, you know. What do you think? Up to 4. And the fallback allocator, of course, would be the allocator passed here. So what this would do exactly? So this would return a stock fallback allocator, allocating using either a fixer. Let's see what it does exactly. buffer equal undefined, fallback allocator, and that. Okay, very cool. So now what we could do, stack fallback allocator. You should create the SFA outside this function, otherwise the return slice will be invalid. Yeah, I was just trying to see how that works, then I would figure out where I can put it. So I think we should probably do it somewhere, like store it in the struct, I guess. Maybe. Although I'm not sure what to call it though, honestly. Not sure what to call it. Maybe stack fallback allocator? Or I think we would have one, like, let's see, physical devices maybe. Physical devices. Okay, should be a stack. Cd.heap stack fallback allocator, and the size would be 4, I think. Is that how it goes? Right. And then we would say in the init function, or is it actually here? Okay. Can we do it here? Okay, let's see. So physical devices. Ooh, what's going on here? Let's call it allocator for now. I don't know what to call it yet. So 4 bytes. Is that 4 bytes? I actually do not want 4 bytes. I want 4 physical devices. Should I do like this or what? Do I need to do this? I honestly do not see a type here. Yeah. So how you would do this? So std.heap.stack fallback and then allocator. Now should we do equals to, well, of course self is equal to what? Do I really need to embed it here though? I wonder. Hold on, let's start by doing something other than this, okay? Let's start small here. I think I have a better idea. Well, not a better, but basically this is not good to try it now here. Let's just go back for a second. Discard, close, don't save. Let's just go into main.zig. Let's remove this version. We do not need it anymore, I think, maybe. And let's go to, okay, so where were we using that? Where are we getting the physical devices? Here, we're getting it here. So instead of passing an allocator there, maybe we could do that trick. Does that make sense? So let's just do this and see how it goes. Okay, so this returns an allocator. Okay, so I think I should pass this SFA allocator here, and of course here just 4 times the size of I think you need to create the SFA outside of this function. Do we? Let's see, hold on a second. So size of c.vk physical device. sfa.get. Would this work by any chance? Well, let's try it, I guess, and find out. It seems to be fine. Well, how would I know if it actually didn't allocate? How would I find out? Is there a way? Let's see, SFA dot. No, looks good. I forgot you're freeing the slice in that. Yeah, exactly, yeah. Fallback allocator. Is there a way to watch out for allocations, how they're made? Like, for example, maybe... Okay, maybe we could debug this and see and find out. Like, we're using it here. So let's put a breakpoint there. And let's try this out. Let's see what it does. Step into. Okay, cool. Advanced with red address. If you're using a GPA, he has a login option. Ooh, login option. Well, let's see what about that. GPA login option. Okay. First of all, I think to remove the breakpoint. Yep. Oh man, this is so long. Do you mean we should do it here, I guess? Look at the config struct. Oh, yeah, my bad. Number of stack frames to capture. If true, the allocator will have two fields. Enable memory limit. Ooh. So we could use this to like emulate, what can I say? Emulate, right? Emulate some kind of limited memory scenario. That's cool. Whether the allocator may be used simultaneously for multiple threads. I think this is it, right? Yeah, this is temporary debugging 8 dimensions. Okay, let's try to add this verbose log and see how it goes. And let's see what allocations are happening. Okay, so it says that it allocates small alloc 96 bytes and free 96 bytes. So it seems to have allocated once, which is interesting. Now, what if we don't use that guy? What if we don't use this SFA? Where is it? Physical device. So instead of this, I'm just going to use the normal allocator and see and find out. Okay, let's go. Alrighty, cool. So alloc 96 bytes, free 96 bytes. I see. So it allocates. Nice, amazing. So this is nice. This is pretty nice. Lovely. Okay, so should we actually create a stack fallback allocator every time the init function gets in? I wonder. I think we should probably create it in it, right? And then just reuse it. Is that it? What do you think? Stack fallback allocator. No, I think it's fine as is. Cool. Oh. Now we have two allocators. Stack fallback allocator main. A dot get. Well, can't we just say dot get directly then? In this case. Oh, don't we have to actually de-init stack fallback or something? No? I do not think though. Yeah, doesn't seem like. So I think it's because of it's inside the stack, right? So there's nothing to deallocate, I guess. Okay, so yeah. So I think it's fine to basically say .get directly in this case. So stack fallback allocator, and then just pass them in. Honestly amazing. And then instead of making this as kind of like what can I say, a magic number, let's call this some constant. I think max, yeah, the stack mem doesn't need to be de-init, right? Cool. So happens automatically. So basically this stack fallback allocator, would it add any performance penalty if you like? Oh, never mind, it's fine. Okay, because we are inside init. Okay, never mind. So okay, so I think I'm gonna call this max stack physical devices, I guess. Max stack physical devices. Let's see where I'm gonna put this here. Const. Oh, actually, honestly, there's no need to call it like this. I think let's just call it max stack physical device. No performance penalty. I think this should improve performance, you noted earlier. Yeah, that's nice. That's very amazing. Max stack physical. Is this a good name? Max stack physical devices. Is equal to 4. Amazing. Amazing. Okay, cool. Let's make sure everything's still working fine. Well, it's not for some reason. Yeah, it does have to be its own variable, seems like. Crazy stuff, okay? Does have to be its own thing. So stack, fallback. Sure, usually constants are snake case lower, but whatever. Snake case lower. Is this the convention in Zig? Or isn't it? I think it is, no? Var. Okay. Alright, cool stuff. Now this works. Okay, so we have another allocation. Let's see if we can get rid of that too. Okay, let's see. Let's see. Dot alloc. So we have this and we have this. What? But where's the allocation that we have just removed now? That's weird. What? Okay, so it's inside context. We used it here. Oh, but right now we have to answer the question. Should we keep this in the context, or should we do it in the get physical devices function itself? That's the real question, I guess. And also here, I think probably it would be better maybe if we do it there. No. Stack fallback. Wow. Well, that's a good design question. Or should I say engineering question, but yeah. I think YouTube is blocking my link. You can find the style guide by searching for style guide on the link ref page. Zig style guide. This guy? Or this guy? Let's look for style guide here. There you go. Okay, cool. Examples. Well, I cannot find constants there. There is these guys. Okay, I see. So they should be like that. Well, but we already have self like this. But anyway, let's do it. Max stack physical devices. Now I think this boils down to one question, which is that is the caller more aware? Types are upper camel. Oh, I see. That makes total sense, right? Now I see. Okay, great. Nice. All right. So the question I think right now we should pose is that is the caller more aware of how much there could be of items or how much needed allocations, or the actual function, like get physical devices in this case? Get physical devices. I think it's better maybe if we put it in the... But then I think we have to store it, isn't it? And we actually need the allocator then. Oh, I see. So hold on a second. Let's go to this function and let's see. So in fact here we're getting the allocator. Well, if we want to do such a thing, then we have to pass an allocator in the init function instead. So you cannot pass another allocator for, well, honestly, I think for now this is fine. We're just gonna let the caller do his job. So yeah, pretty cool. Now let's actually go to the other thing. Where is context again? There you go, context. And now let's optimize out the other allocation if possible. Where is it? Stack fallback allocator. Stack. Okay, so we're using it for physical devices and also for selecting a key family. Now, what the key family does with this? Where is it allocating? It's allocating here. So this basically boils down to how much vacay key family properties you have. I think, right? Is that the only allocation here? Yeah, seems like. But hold on a second. Do we really need an allocation here? Yeah, we do. We do. Okay. Count. Alright, cool. Cool. So how much key families I have personally? I think I have 4 if I remember well. But let's check out the database though. That would be a great thing. So Vulkan what is it called? Vulkan database. Anyways, hardware database. Anyway, let's go to Vulkan stuff and let's look for, well, maybe let's look for the most common or something like that, or the latest GPUs or something like that, just to get an idea of what's there. So for example, this Radeon RX feed Vega, I think, is it called? So it have 3 Q families. Let's look for some couple other stuff. Let's see some NVIDIA RTX, something high level hopefully. Why NVIDIA stuff doesn't show up? Oh, hold on a second. NVIDIA? I honestly do not know which one is better. Let's look, for example, this one. How much key families? It have 5 key families. Alright, for me, I have 4. Well, is there like 6 key families in some kind of device? I wonder. Let's look for some other ones. Find out, I guess. Let's look for some, like, I don't know about GPUs, honestly. Let's look for the best GPU, the AMD GPU, I guess. Something along that lines. AMD Radeon RX. Okay, let's look for that, I guess. For example, this guy, 3 key families. All right, so I'm going to go with 5 key families, I think. So yeah, pretty much. Okay, well, let's look for where we created that fallback allocator stuff. Let's go. So stack fallback. Can we use the same stack fallback maybe? Yeah, honestly, can we use that here? Let's see. Well, no, we cannot. I mean, well, we kind of can, but there's no need, I guess. So there's two options here. We could either say plus, and here, let's see, say const max stack. Let's say instead of physical devices, this time it's gonna be queue families, right? Let's say 5, for example. Or maybe let's just go ahead and make it 8, just to round it up to the what is it called? I just like 4, 8, 16, stuff like that. Anyway, let's go ahead and do this. Times. I would just create a new one on the spot if you don't need to return any allocated memory. So you think it's better to do that? Alright. Let's go ahead and do that. Stack fallback. Now we have to call this something more meaningful. Physical. Well, honestly. Okay, fine. Physical devices stack fallback, and oh man, that's a huge name right there. Oh my god. Okay. That's a huge name. Okay. I think I'll just remove this fallback maybe. Yeah, I think I'll just remove that fallback. There's no need for it. It doesn't add anything to the context. So physical devices stack. There you go. Let's create now another one. Queue family stack is equal to cd.heap stack allocator. Instead of physical device, now it's gonna be vkqueue family properties. Queue family stack. Okay. What I've done, man. Stack. Okay, let's go. Queue family properties. Stack. And well, stack. Try highlighting a repeated word, then Control D. Control D. Ooh. Okay, cool. Cool. Well, queue family property stack. Well, then people would think that it's actually a stack instead of stack fallback. Oh my god. Well. So you said this, Control D, Control D, Control D. But now I'm not sure if I'm not touching any other place in the code where it's the same thing. But yeah, so physical devices, stack allocator. Ooh. Stack. Okay, cool. Ask to go back to single cursor. Oh yeah. Stack fallback. Control Shift plus D, I think, for all occurrences in the whole document. But that could be tragic because you could maybe edit something that is not visible on your screen, I guess. Another one is F2 to rename symbol. I'd like to stay away from F2s and F3s and F4s and stuff like that because I'm required to basically hold another key called Fn to be able to actually reach that up. But yeah, anyway. So queue family properties, stack fallback. What's the problem with this guy? I think right now we basically need, oh, this could be constant. And then we basically say const queue family properties stack fallback allocator. .get, right? I wonder if there's some convention when you have like something, some allocator, and then you want to get that allocator thing from it, what you would name the two. Currently I just removed allocator from this one and added it to this one, but anyway, so now we're going to plug this in here instead of the allocator. Let's go, and there you go. Although of course I'm going to make this near where it's being used. Okay, cool. Now zig build run, and let's go. We're not making any allocations anymore. Honestly, very interesting. And now, since I have just four queue families, let's see and find out if I say 4 here. Okay, good. No allocations, but if I say 3, now it should allocate. Well, what the? Why didn't it allocate in this case? Is there some bug here? Something's, oh, I'm glad I tried that out because, well, copy paste. Okay, amazing, perfect. As you can see right now, there is an allocation. 3, there should still be an allocation, but 4, there should be no allocation because I have 4 queue families. Let's go, works, perfect, amazing. All right, that's pretty much it. Although I'll round this up to 8 for now. And yeah, that's pretty much it. We have basically optimized all the allocations for now, I guess. Pretty much. Cool. Lovely. Amazing. Okay, what's next now? What's next on the list? The other thing I wanted to try out, I think, is, let's see, is the build system. Currently we're using this kind of like sh script here in compile shaders and translate C imports. But to be as cross-platform as possible, I think we should rewrite this in Zig itself. So yeah, I think that's what I'm gonna try to do right now. Okay, so I'm gonna create a new file. I'm gonna call it setup.zig. So this would basically be the pre-build. Well, what about pre-build instead of setup? So what do you think, setup or pre-build? I guess I would go with pre-build for now. It seems more descriptive, I guess, for this case. So basically this script would basically hopefully have everything to do with our tools, would, for example, translate C imports, generating files, you know, stuff like that, translating shaders, etc., etc. I think that's what we're gonna do here, hopefully. So let's start a new file, pubfn main void, and basically this should be run using zig. I think run prebuild.zig. Yeah, basically. So you just say zig run prebuild.zig and it would go ahead. Let me know, guys, if you think that prebuild, what should we name it? Prebuild or setup? Prebuild or setup. Okay. Pubfn main void. Well, I already did such a thing before. But let's see, where is it? So we could inspire from it. Okay, let's just go to GitHub. Let's see. Codotaku image viewer. Let's go. And setup.zig. Okay, so this is what it took to do it. But I kind of went overboard there, honestly. Kind of over-engineered that, I think. So, anyways. So, we would have translate headers. Okay, let's just have fn translate C imports. And it would basically, I think, give it some sort of file, maybe. Make path. Translate C imports. So it should hopefully basically do this. For now, let's just go with void until we see otherwise. Okay. So import std, let's go. I'm just gonna call this allocator, honestly. And so we need here allocator std.mem.al, oopsies, allocator, let's go. Other than that, we need the file path, basically. What zig calls them though? Let me try to find one. So std.file or what? Do not remember how you do open files. I think so. I see here absolute path. So I think I would go with relative path. Honestly, let's call it translate header. Let's just call it file path. Or header file path. Let's just go with file path. Okay. So this would be a U8. Well, const U8, I guess. And then there's maybe no need for this. Oh, this actually gives us argv and all this crazy stuff. Result std out. Oh yeah, so I remember that exec right here actually allocates memory. So it spawns a child process, waits for it, collects an std out and std error, then returns. If it succeeds, here we go. The caller owns result, the std out, and result std error memory, which means we have to free them ourselves because we own them. So I see what I've done there. Try current working directory. Okay, let's see what we have done here. And of course, let's call this allocator. So we have to free them when we're done, because we own those. Actually, I'm going to leave std out. I'm just going to return that one, I guess. Honestly. Return result.std out. If result.std error, so basically there is some error. So std error should be a length bigger than 0. Then, well, I'm going to actually return. Well, let's see. Instead of panicking, I think let's do something else. So that's a U8, okay. Cool. So here we would basically, I guess, return error. Error dot failed. Or failure. But anyways, if result is the error, return that. Otherwise, return result.std out. But how do we pass in the std error though? I'd like to pass it up. So I think maybe we need a union for that. Let's call it results for now. Tagged union, maybe. Let me see, what about unions? How unions work. Tagged unions. So okay, not okay. Cool. Okay, not okay. So I think there would be a Boolean value right there indicating if it's failed or succeeded. And there would be 2 values. Honestly, there's no need for 2 values, is it? Well, I mean, oh yeah, there could be only std error or std out. Yeah, that makes sense, I guess. So, but there's no need because, well, both are strings, right? Yeah, both are strings. Well, I guess that makes sense. So for now, let's say maybe status, I guess, or is success, which would be a Boolean, and then the message, I guess, which would be a U8. What about that? Why I have a problem with this guy? Oh, struct. Let's go. And then maybe this could return now instead of this. Maybe it could return result, I guess. I should call this maybe command result. Maybe this is called output. Okay. Okay, cool. Now, what I'm going to do, I'm going to remove this for now. Now, if result std error exists, then we're basically going to return result.std error. And what we're going to do, we're also going to make sure to free the other ones. Hold on a second, how we have done it. Allocator.free. Okay. So allocator.free, the memory in this case we would deallocate the std out, and we would leave for the user, or the caller should I say, to deallocate std error when he's done with it. Otherwise I would free results.std error, and I would return for the caller std out. I think that makes sense. So yeah, pretty much. Okay, cool. So now what we would say, const maybe c imports is equal to maybe translate header, and then the file path would be, in this case, at least for now I guess, where is it? It's called c.zig, is it? No, cimports.h. okay, so it's called the cimports.h. and the allocator, we need the GPA, const general purpose allocator is equal to general, well, cd dot a heap, right? General purpose allocator, let's go. And then defer cd.debug.assert that general purpose allocator.dinit is equal to .ok. Okay, now you would say, we would grab the allocator, of course. Well, const allocator is equal to general purpose allocator. Let's go. Now let's pass in the allocator. And for now though, let's just std.debug.print the result. And see what's happening right there. Zig run prebuild.zig. Oh yeah, this should be var. Okay, I forgot about this guy. Yeah, there's need of an error right there, and that means we gotta try. Where is try? Here. Try translate header. Oh, I see. So this should be command result dot is success is equal to false in this, true in this case, and the output would be equal to this guy. Otherwise false here and std error here. But of course I almost forgot about something, which is to go ahead and basically say allocator.free C imports dot output. Okay, cool. And core dumped for some reason. Huh? Segmentation fault. Really? Why? That's crazy. Max. Why that's happening? Oh, not this one. Well, maybe we have to go to lunch.json now. And maybe add another one here. Another configuration possibly. Lunch name debug pre-build, I guess. And here we could say slash, well, the program is basically Zig. So Zig run pre-build.zig. I think it would basically say here run and here pre-build.zig, I guess. Now let's try this out. Cool. Alright. What's the problem with this? Stop reason exec? What? That's crazy. Honestly, no idea why that would happen. Okay, let's try to say again Zig. Let's try again to say Zig run pre-build. Zig, it would segmentation, it would give a segmentation fault, and then I would say core dump ctl debug. And yeah, it seems to be the same exact thing for some reason. Weird. That honestly doesn't help too much. Where's the current working directory, by the way? Maybe it's because you're returning result.stdout error, which are local pointers. Maybe just return results from that function. Result. Local pointers. I mean, they're allocated though. They're allocated. But honestly, I guess let's try it maybe. Let's just do something pretty easy, pretty simple. I'm gonna remove all this craziness. I'm going to, for now, comment this out. Just do this for now. Zig run prebuild.zig. Okay, no problem there. But if I execute this guy, what happens? The file path in this case is cimports.h. Same exact thing. Oh, but this is memory address leaked. So let's just first of all make sure to allocator.dalloc, or well, free result.std out and allocator.free result.std error. That seems to be fine. Okay, well, defer and print .debug.print. Let's go this guy and then give it result.std out. Yeah. Okay, so it works like this. I do not know why it doesn't work this way. That's weird. Weird. So weird indeed. Well, honestly, let's not over-engineer it. Fine, if this works, we're just gonna go with it. So yeah. Anyway. Alright, so now we should pretty much open a file to store that guy. So this is that thing. Okay, cool. Now let's make a file and let's go back to our, there you go. What is current working directory here? Result is a local which gets invalidated. So result.std out is a slice which also get invalidated. But isn't std out is actually allocated? I mean, I had to free it. I had to explicitly free it. I mean, I guess it's allocated in the heap, so that doesn't really make too much sense for me yet. Try current working directory, create file. So how do you create a file, I wonder? So const file is equal to std.fs maybe, .file? No? Or create? Okay, create file absolute. Well, this is absolute file. The stdout.ptr still points to valid memory, but the slice itself is invalid. Woo. Well, that's actually weird. Is there a way to actually solve that? I wonder. So how did I get the working directory here? .fs.cwd current working directory. Okay, now here I could say hopefully create file. Near the subpath, which is basically src slash what is it called? c.zig, I guess. I think that's what I called it there. And the create flags that I used here is nothing, basically. At least seems like. And then here basically we're just going to file, I guess, dot write or what? Dot writer. Hold on. First of all, the fur file dot close. That's the first thing we have to do. But I think this could fail, right? Yes. Try. And then file dot write all. The bytes would be result dot std out. Right? Now error is ignored. Okay, try. Okay, now let's actually remove that c.zig file. Move to trash. And there you go. Done. Now zig build run. Amazing, perfect. It works. Lovely. Okay, cool. Pretty cool. Indeed. Although, can't we access translate C directly? I do remember something like that, maybe in the standard library or something. Like, for example, there's a tokenizer at least. cd translate dash c sig. Okay, let's look for maybe nope. cd docs zig. Let's go. Let's look, for example, for tokenize. Okay, so there is a tokenizer there. It's inside that. What about translate? Let's see if translate is okay, but that's the build. Oh, so that's build. We cannot use that, I guess. Add translate C. Step translate C. Okay, fine. Anyway, so for now we're just going to use a command like this. Other than this, there's also compile shaders, which should hopefully go through all div/shaders and basically go ahead and translate, like compile them and put them there. Now, before we do this, we should be able, we should get the arguments of passed to pre-build. So how we would get that, I guess, with the let's see, args alloc, I guess. Is that the case? Or args with allocator? I think maybe this one, args alloc, if I remember well. So how we do this? Well, before we do this stuff, let's grab the arguments. Is equal to std.process.args alloc. We would give it the allocator in this case. It would give us the arguments. Now there is another one which is called args iterator, I think, or something like that. I don't know. Arg iterator, I guess. But the thing is, if I remember well, someone told me that it's actually not cross-platform. So we're going to go with this guy. Well, of course, defer std.process, I think, args free, and then you would give it the allocator, and then the arguments, I guess. Let's just make sure everything works fine. Yeah, try. So I think right now we got the arguments. Nice. Okay, so let's try to get the first one, I guess. Let's see. Print. Of course, I'm gonna go with 1 because 0 I think would be the file path. And basically, depending on that, we would do a separate task. Index out of bounds. Okay, that makes sense. But if I say like translate, oopsies, we have to add that dash dash, so it actually passes it to the program. Okay, so that makes sense. So of course, first of all, I'm going to assert that arguments.len is actually greater than 1, or maybe equal to 2. Honestly, it doesn't matter. Let's just say greater than 1. Okay, and if well, we're going to switch on arguments. 1, the first argument, and depending on that, if it's translate, I guess we could basically do this stuff. Cannot switch on strings. Well, how would I check if its string is equal to a string? Well, oopsies. Well. I think maybe I have to use std.mem.all equal or something like that. Comp time. There's two things here. There's this one and there's this one. Oh no, we need this guy. And comp time t type. In this case, I think it's u8. And here it's basically arguments 1. And then we could say here translate. Now, if this is the case, allocator.free. Is that the case? Terminal. Cool. Now, I would like to do something even better, which is we're going to basically loop through all the arguments, of course, starting from 1, not 0, because 0 is just the path of the file or the executable. And basically if we find translate, we're going to translate. If we find something else, like you could say translate, compile shaders basically. Like you could do multiple tasks at once using multiple arguments. So that's nice. Okay. So we're going to go through all the arguments. So arguments, and we're going to start from 1. Basically skipping the first one, which is basically the path of the executable. And here, this is the argument. And we're going to basically check that guy. If it's equal to translate. Cool. Otherwise, else if std.mem.equal, instead of translate, for example, here right now we're going to say compile shaders. Here let's call this guy translate C imports. So if compile shaders, then what we could say, so this is the commands that we should do. First of all, we have to make sure to make the directory rest/shaders if it doesn't exist. Then we have to call glslc for each file in dev/shaders and basically compile those into and put them in rest/shaders. That would be cool. So I wonder if there's a function already to do this one, rest/shaders. And one thing I want to look into real quick is if we go to src, right, so there's no rest. Okay. So, okay, let's start by the first one then. Compile shaders. Wow. Let's see. So std.fs, I guess. Create. There is no directory there. I wonder. Make there. All right, cool. Make there. There's absolute. Okay, but no, we want, let's say, current working directory, I guess. And then we could after that say make there. Nice. And then you would say the subpath. Now I wonder if it would actually traverse the whole path thing. So creates a single directory with a relative or absolute path. To create multiple directories to make an entire path, see make path. All right, that's exactly what I need. To operate on only absolute path, see make there absolute. Okay, so we need make path here in this case. Nice, amazing, perfect. I'm glad that such a function in the standard library I do not have to make it. That would have been crazy. Okay, now the subpath would be in this case, and it also of course could fail, so let's say try. And yeah, other than that, where's the thing? Compile shaders. Okay, so src/rest/shaders. Okay, cool. src/rest/shaders. Make path. Now let's just make sure that works fine. Compile shaders. Make open path will also return the there if you need it. Ooh, make open path. But why we would need the path? Let me see. cd.fs.cwd.make open path. If you want to write the file there, this function performs make path followed by open there if supported by the OS. This operation is atomic. It is not atomic on all operating systems. Now, the problem with this is the fact that we're going to use the command, okay? We're going to use GLSLC, which basically just needs the path, and it requires the... But can we make GLSLC give us the compiled shader bytes, maybe in std out, and then we could write it ourselves? So if we do want to do any kind of intermediate step for some reason, and then we could do it, I guess. So let us see. GLSLC output to std out, Vulkan. Okay, the Arch Linux manual. There's a lot of cool stuff here. By the way, if I didn't actually make the shader file extension .comp, then I would actually need to pass another parameter to GLSLC to tell it what shader stage that is. In this case, it's compute. Although the problem with this kind of setup is the fact that you're not allowing, I think, Uber shaders, where basically you could have one shader which contains compute, geometry, tessellation, fragment, vertex, anything you want. Although in this case it doesn't really matter because we're only going to be using compute though. But yeah. OIC seems easier to pass the file name to GLSLC. Yeah. Although if it can actually tell us the file in, let's see, hold on a second. Also, we need some way to check if GLSLC is actually valid. So we can let the user know that you have to, let's say, download the Vulkan stuff to get GLSLC. I wonder if we can do that or not. Or we could basically just detect errors and do accordingly. But yeah. So now -o, let's see, specify the output file name. It can be used when there are multiple files. Okay, our file name of dash, I think that is, represents standard output. Okay, cool. All right, let's try this out, man. So, oopsies. So if I say -o dash, all right. It actually gives me the bytes in std out now. Honestly, very amazing. Okay, lovely. So we could now, we're going to use then this make open path instead. We're going to pass it the subpath, as you can see, and then the open there options. Let's see what options are there. And also I think I should try this up. So const there is equal to try cd.fs scwd. This is the current working directory. Okay, let's go. Const current working directory. Should work fine. Yeah, I wonder what are the possible options though. Sadly, I cannot click on them though. Well, anyways, let's just go with this for now. Directory. What is this? This is the shaders directory, exactly. Although, is there some better way, like, to make sure it is 100% cross-platform? Or is it already doing that for me, I guess? Maybe. Oh, there you go. I can actually right now. True means the open directory can be used as a dir parameter for functions which operate based on open directory handle. When false, such operations are illegal behavior. True means it won't dereference the symlinks. Okay. What I wanted now. Oh, I wanted to see the open dir. Where is it? Main.zig. No, pre-build. Let's look for make open path and what it does exactly. Okay, so it's you call in make path, calls make there recursively to make an entire path, return success to the path already exists. Is this cross-platform or not? Ooh. What? It's calling, it's telling us. In Windows, it actually does this somehow. Well, that's weird. Okay, so how we would actually return a subpath that is cross-platform? Is there like some join function? Okay, there is join. So there's this join function, but unfortunately this one is not comp time. This one needs an allocator and stuff. Honestly, I don't know, but let's just, I guess, do it. Where is it? Pre-build. Is the allocator. Let's give it the allocator. And then the path. This would be, is that an array or what? I guess so. So you cannot do this, I guess? Do you really have to say path like this? Path is equal to ref works too. Oh, cool. Like this. Res. What's next? Shaders. Cool. Can this be inlined by any chance? Ew, it seems like. Cool. Nice, nice, nice. Now we could pass this there, I guess. But this could error, so let's say try. Oh man, that's so big. Let's actually put it into its own thing, I guess. Const subpath. Const path. And here you go. Shaders. Directory. Path. Oops. Okay, cool. Add a comma after the final arg will make zig FMT split into separate lines. Oh yeah, gotcha. So that's interesting. Let's go back, I guess. Oh, what's happened there? Well, anyway, let's do this. Let's do this and this. Is that it? No, that doesn't seem to work out that way. Oh, never mind. I think I should remove this first. And if I add a comma right now, let's go. Nice. That's much cleaner. Okay, so now we have the shaders directory, I guess. And now we could do basically, I guess, the same exact thing. But first, we need to go through all the directory, right? So src res, what? Not. Actually, we should go through dev shaders first. So dev, then shaders, dev comma shaders. Cool. Now let's go through all that directory files, how you do it. I remember there's like an open iterable, I guess. Make open path iterable and open iterable there. What's this and what's that? There.walk and there.iterate, if I remember. What about this one? There.walk. There's no walk. Oh, subpath. I do not think we need recursive though. Maybe. Oh, actually that would be cool. So you could basically organize the shaders without having a problem here. So there's open iterable there and make open path iterable. I do not really know what's the difference. Hold on a second. Let's go to walk and iterate are methods of the iterable there. Yeah, seems like. So this function performs make path. Ooh. Followed by open iterable there, supported by the OS. This operation is atomic. It is not atomic on all operating systems. Okay, make path. Isn't it the one that we have actually just done? Really? Are you kidding me right now? Make open path. It seems like it is the one. Make open. So we do not, I think we do not need that make open thing, right? Make path, right? Am I right? But this is not make path. This is make open path. What weird. Yeah, so change make open path to make open iterable there. But hold on a second. The thing is, this seems to perform make path, not make open path. So we cannot use it in this case, I think. Can we look into the source though? Let's look into the source just to make sure. Okay, look at that. So it's using make path, which is not like make open path, which we're using here. Because make path cannot actually go ahead and create Well, it is called that, but at the end of the day, look at this. It's actually doing make path. So no, we can avoid one call to NT close. So no, we cannot use this actually. So let's look for the other one. So what is the other one? Yeah, exactly. That's what I'm saying, is that you cannot use that because it's actually using make path, not make open path. That's the thing. So oh, but this actually is subpath. Okay. Okay, let's actually use that. Let's try it out, I guess. Open. Make open path iterable. I think it will work. Okay, sure. Let's try it. Subpath. Let's go. No need for this anymore, I guess. And now actually can't work in directory. Oh, what we're doing here? What? Okay, I think like this. That gives a directory. Okay, cool. Now this open their options. I think we could just go away with that. And now this gives us an iterable there. Now I think we could basically maybe, hold on a second. First of all, let's do this. Nice. Now maybe we could say for this. Maybe here we could save file, I guess. But of course, this should have a try. And then here, I don't know what this returns though. Okay, it returns a iterable there. Oh, it gives us an iterator then. Or should I say iterable? Okay. I think they're next function, right? Yeah, I guess. So let's go back. I think they should probably actually go to yes, now you can walk or iterate on that. Well, there is a walk statement there, I guess. But hold on a second. Let's make this into its own thing. Const iter for now. And then this gives us an iterable there. That's the iterator. So you could say iterate, right? Hold on, let me just go here. Honestly, iterable there. And this is all the stuff you could do. Recursively iterates over a directory, must call walker.dinit when done. Ooh. Or iterate. Okay, interesting. Walker. All right, let's go back now. I guess I understood now. Understand, right? The walk. And this is basically the walker. The walker. Okay. Now, of course, this could return an error. So, well, I guess this should be like this, basically, first of all. Or maybe, in fact, we need to do it step by step. Right, I think so. So this is the iterable there. Yes. Okay. Next up, it would be the walker. But do we really need to actually de-init this guy? Iterable there. Close. Oh, I see. Rebuild.zig. Well, defer iterable there dot close. Let's go. All right, cool. And the next thing would be walker. Iterable there dot walk. You would give it an allocator, and you have to defer walker, I guess, dot de-init, I believe, and then you would give it the allocator again. Now it could go maybe through the walker. I mean, let's look into the walker. There's a next function. Okay, cool. So try walker.next, I think. And then right now you actually have a walker entry. Until next or de-init is called. Then the base name and then the path. Okay, so you're getting the path. And also you're getting the kind though. So I should make sure that it is a file though. Okay, cool. So let's make sure that's a file. So this is called walker entry, or basically entry. And then here we have entry dot kind. Okay, so I guess let's switch on entry dot kind maybe. And or since we only doing one thing, let's just say if entry dot kind is equal to dot file, then we could do what we need to do. Cool. For now, let's just try to debug print, and let's say s, I think, and you would say entry dot, let's see, entry dot base name or dot path in this case. Let's try path, and of course I always forget terminal, zig build run, zog. Zig build, oh, I see. Zig run pre-build or zig. Okay. No field or member function named next. Okay, I forgot to try this out. Alright. Cast discard qualifier. Where? In here. Okay, var. I believe it would be the same thing with walker, right? And then it expected 0 arguments, seems like. What? Type fs optional fs iterable there dot walker entry. Why? Maybe we should say actually while. Yeah. Yeah, that's what I was missing. And reached unreachable code. Amazing. Perfect. What's wrong, bro? Oh yeah, never mind. It just, I need to actually add an argument right there. Cool. But honestly, since we're here, let's just say if less than 2, I guess. Or honestly, there's no need for this since we're looping through it, you know. Okay, great. Now let's actually try to compile shaders. So compile shaders in recognized extension of parameter. What? Oh, I see. I have to add that guy. And core dumped. Amazing. Yeah, there is some kind of yeah, join. Oh, I need to actually deallocate this guy. Man, that's a lifesaver right there. Otherwise we would have had a memory leak. So path. Oh, I forgot. Defer allocator.free path. Yep, there you go. It says simple.comp, which is interesting. Simple.comp. So I think right now, well, hold on a second. Really? It's only given us the path like relative to dev/shaders though. Dev/. Oh, we already have that path. So what about the other stuff in the entry? So there is some other stuff there. There is the containing directory. The containing directory. Okay, can I print that one? Just so I can see what's going on there. Alright, nice. So we could basically use this. Nice. So now let's get this guy. Basically kind of a similar thing right there. And we're going to put this here. Now instead of zig translate C, we have glslc. And after that you have, yeah, there you go. So here I need to give it the path, the full path. Or otherwise, I think if I remember well, there is like a CW, oh, there you go. So there's CWD there. So I guess I could say .cwd there, maybe? But hold on a second, let me check. Okay, fine. Let's try that out, I guess. Is equal to entry dot dir. Okay, cool. Now maybe I can say, instead of that guy, I could say base name, maybe. base name. And then we don't need this guy, we need this ng.basename dash dash. Is it? Oh no, dash o. Okay, dash o. And after that you would just give a dash so you could put it in the std out. And yeah, that's pretty much it. Okay, cool, lovely. And now we need to create the file. Amazing. Now honestly, for now, let's just try to print that guy for a second there. Results, just to make sure everything is working fine. Yeah, works. Amazing. Okay. Amazing, amazing, amazing. Now I just need to figure out where I basically need to open the other path, the other directory, which is src/res/shaders. I would like to call this input path. Oopsies. Input path. Alright, cool. Now let's take the output path, which would be the same exact thing, but instead of the shaders, src/res/shaders. I think the dir you want is iterable dir. No, that's the input directory, and I'm actually using it here, you know, in the current working directory for the command. But right now I need the output directory, which would be src/res/shaders. So this is another directory, basically. So yeah, src/res/shaders. Okay, cool. Yep. And of course the defer, I think, to make sure. Oh, let me make sure this defer is right here. And now we could say defer allocator.free output path. Amazing. All right, now I think we need to open up the file. The directory. So we could basically create a file there directly. So we have the output path, and then hopefully we open up the output directory, which would be equal, I guess, by the way, I can just say current working directory here. Okay, current working directory dot open there. Yep, the subpath would be output path, and the arg's nothing. And of course, defer output directory dot close. Did I close the other directories too? For example, current working directory. Do I need to do that? I don't think. Yeah, I don't think. Anyway, Other than that, right now we could basically say output directory dot create file. And right now, instead of doing this mess, I could basically say entry.base name, I think. Although I'd like to append into it .spv. .spv, wow. How would I do that? And so there's join, but that's for path. But how would you like append two strings together? Of course, we do not have entry base name at comp time, I think. So maybe we could find something in mem. Mem.concate. Yeah, I thought it would be there. Concate, you would go with allocator and then comp time t type, which would be slices. U8, I think there. Right, I think. Hold on, what? Slices. No, I think it would be slice U8, maybe something like this, I guess. And then you would probably say slices. Maybe I could use this trick right here, maybe. You only need U8s there. Okay, cool. Interesting. Entry.base name, comma, .spv. Although honestly, is there something like some platform independent way to add an extension or something like that? I wonder. cdlfs. I don't think there is. Might have that if I stop. There you go. Oh, but this actually returns. Let's look what it does. Well, in fact, it just looks for a point right there. So yeah, I think all the platforms maybe use this way of doing it, so fine, anyway. Okay, cool, amazing, perfect. Copies each. So I think I have to probably deallocate that. Okay, so const output file base name, I guess, is equal to that, or output base name. And then of course make sure to here try and here defer allocator.free output base name. Let's go. Now instead of entry.base name, we would create file with that terminal. Where is this? Oh, I changed something I should have not changed, I guess. Yeah. Yep. In the future, maybe use an arena for a program like this so you don't have to free everything. Well, actually, that is super true. That is super true. We could do it. No field or member function named close. That is honestly very true. Yeah. Allocations are everywhere, so that's pretty useful. No field or member function named close in error. Yes, close. Well, try yetu. Try. Oh man. Cast discards. Okay, var. Well, finally. Finally. Okay, let's try this out. All right. Let's say we have removed this guy, I think. Rest/shaders. Well, shaders, for example. There you go. File not found. As I said, but what? Oh, open their output path. Well, output path. So this is where we need that open thing. Okay, hold on a second. Well, I do remember there was something that we found about make there, yeah. Make open there or open path. Is that the case? I think so. Yeah, I guess so. Now. And there you go, amazing, perfect. Awesome. So that works perfectly. Cool. Now, if you basically add another shader, let's say, you, for example, what could I do? Well, how do you actually duplicate a file here? I guess we could just copy and paste it. There you go. So right now I have a copy of a shader. Let's try to run it again. And there you go. Although there's one thing that we have to make sure to do is the fact that we need to remove the already existing compiled stuff. Why? Too simply because you may think that you're using the newly compiled thing, but you're not, since it didn't get overridden because of something like, for example, an error or something. This is the first one. And second one, if I remove right now this file, this shader, and then rerun this guy, nothing would happen here. This wouldn't update because we're not removing first. So yeah, that makes all sense. So let's delete this guy. Create file will overwrite the file. Yeah, it will overwrite the file, but the problem is we're actually going through the input shaders, okay? Not the output shaders. So not the output files. Now, since we're doing that, if there's no input path, you know, you got the point, right? Exactly. That's why we have to first of all clean up anything if there's any, and then regenerate. Okay, cool. Pre-build.zig. So how we can do that? Let's see, compile shaders. So after current working directory maybe, or actually after getting the path, output path, output directory. Okay, there you go. It would be def/shaders. All right, so we need to figure out right now how to clear up all the files. So we could delete. We could delete file There's also delete dir, and there's delete file, delete tree. What is this delete tree? Does this do what we want? Delete tree. There you go, it sees inbounded array there. Cool. Stack. Process stack. So it's opening the iterable there. It's deleting file. So I guess this is the one, maybe? No? Honestly, I guess let's just try it out. Maybe? Well, if we say, gotta run, see ya, goodbye Travis, have a good day. Or I would just basically delete, honestly, the directory. Make open, of course, before creating it. Before creating it, okay. So, subpath, output path. Let's go, and instead of, well, current working directory, delete directory, and try to delete it. To delete a directory recursively. Okay, I guess let's try this out, maybe. File not found. Yeah, it's not found, so that's fine. Well, honestly, I guess I don't care about the error. What about delete tree though? I think delete tree would be better. Okay, cool. Now let's say this is here, for example, for a second, so you could remove them. Why it doesn't remove it? No. Well, that doesn't do it. That doesn't do the trick. So let me bring back that guy into dev shaders. Okay. And honestly, I'm just going to basically after opening output directory. Okay, I'm just going to go through all of it. So var iterable output iterable there is equal to try make open path iterable. Make open path iterable. Should I really do that? Okay. But instead of input path, this should be output path. Ooh, what? No. What I'm doing here? Actually, no. Let's see. Output directory dot open iterable. It doesn't seem like there is some function for that. So you basically have to give a subpath. Makes sense, I guess. Well, current working directory. Well, honestly, make open path. Didn't I actually create some kind of function for this? Here, maybe? No, I didn't. Okay, cool. So I need to go through okay, fine. So we're basically going to say current working directory dot delete directory. Yes, delete directory. And I think it's this easy though. Delete there, is it? Try delete there. Okay. If the directory is not empty, oh well, then that means I guess we have to use delete tree then. Let's try this hopefully. Cool. What if we do not have this guy here? Move. And let's go. It works. Lovely. Now let's just get it back to there. Move. Nice. Amazing. Now I could basically let's say we do not have rest shaders for now. Delete, move to trash. And let's say we do not have c.zig. Delete, move to trash. And now I could say compile shaders and translate. Translate C imports. And there you go. Works perfectly. Nice. We could even have like a clear function, or I guess. Yeah. So I'm going to take a break for now. I'm going to come back later. Alright, back. Let's go. Close. Don't save. Alright, amazing. So now, instead of these frees, as he said, probably in this case, we'd probably better go with an arena allocator. Arena allocator. So we could free everything at once. Amazing. Because this script is like just one shot, you know. So that makes total sense, honestly. Arena allocator init, I guess. Oh, but you do need that guy. So let's go back a second there. And now let's just say var arena is equal to arena cd.heap arena allocator. Oopsies. Arena allocator dot init. Let's go. Oops. Init. And then here general purpose dot allocator. Let's go. Now there's no need for that. Const allocator is actually equal to arena.allocator. Then after that, I think I could basically say, arena.free, isn't it? Or dinit, I guess. I think. Just making sure that's the case. Okay, I think that's pretty much the case. So I do not need to freeze stuff. Amazing, perfect. So let's go to pre-built. Arena init. This would really clean up the code very much. So defer, of course, defer arena.dinit. And basically, we no longer need to freeze stuff. So let's look for everywhere where we're doing the .free. Okay, so all of these could hopefully go away. I think. So I guess we do not have free anymore. Oh, actually we have it here. That's much, much cleaner. Man. Arena allocator is just perfect for such one-shot stuff. Like applications. So yeah. I think that's pretty much it, maybe. Yeah, I think so. Amazing, perfect. So now the code is much, much cleaner than before. Nice. I do not have to worry about free and stuff anymore. Could just go wild at this point. Okay, cool. Now I think the last thing would be to just add another guy called else if stdmem equal clear or clean, just like a build script kind of thing, or build make file, you know. This is kind of something similar basically. So if it's clean, then we're basically going to clean the stuff that is generated by calling any of these guys. So starting by, of course I do need the current working directory. Honestly, this is something very useful for anything. So I'm just going to put it on a wider scope. Something like, I guess, like this here. Other than that, there is also this output path, this input path. But why we do need make path here though? I do not think we need that. Yeah, well, for the input path, no. Yeah. So open iterable there. We do not need it for the input, only the output. Okay, cool. Now let's just do this again, making sure everything is working fine. Nice, nice, nice. Now what we would do is clearing up the output path and clearing up the translate stuff. So the output pass is this guy, join. And then basically output directory. Well, I'm just going to try current delete tree. And so yeah, pretty much. And that's pretty much it, really. And also, of course, we have to clean up the translate stuff, which would be in here. Oh, I forgot about this one. Interesting. Well, can I just say a CDF path join? Let's put a comma there, I guess. And then let's do this. This. Okay, great. Now instead of... Oh, what's going on? No. Okay, cool. I think this is src, and here's c.zig, right? I guess try. Yes, try here. Nice. And the other thing would be, I guess, so now we basically have to get this and take it here, and here delete file. So you'd give it a subpath. Okay. Delete file error void. Okay. No need for this. And now it should work out. Cool. Now if I say zig run prebuild .zig, honestly I'm just going to call it setup. I think that makes more sense, maybe, or tools. Setup tools. Anyway, never mind. Let's just keep it as it is. Prebuild.zig, and then let's just clear everything. So it should clear rest/shaders. It should clear zig.c.zig. So it's all still there. Weird. Oh, clean, not clear. So yeah, it's all gone. Amazing. Perfect. Now prebuild.zig and the launch.json and the main.zig file. What we have added here. Amazing, cool. Now one thing I guess I would add is that this verbose log for now, maybe for now I could say false, or honestly we could keep it, I guess. Anyway, so that's pretty much it, I believe. Of course, we still have to create right now the compute pipeline and stuff. And oh, also let me make sure I've actually updated the file name here. So it's rest/shaders. Well, Let me translate C imports. And let me compile shaders. Cool. Now, where is the compiled shader? Here. So res/shaders simple.comp.spv. Let's make sure this guy runs fine for now. Sig build run. Cool, amazing. Now let's actually update the readme. Perfect. Okay, cool. Zig pre-build copy. Zig. Honestly, there's no need for this. Let's just say build instructions sh, and there you go. So zig run prebuild.zig, and then translate C imports and compile shaders. Copy. Nice. If I say zig run prebuild.zig clean, okay, dash clean, then zig, oops, so of course that wouldn't work. But if you stayed this works. Perfect. So let me make sure that zig cache is git ignore is fine, I guess. And honestly, hold on a second. Prebuild.zig. Yeah, I'm deleting the res shaders, not res. Okay, great. Now the thing is, if I go to git ignore, I should basically just make sure I'm saying src/res/shaders. Res is fine. Alright, well, if we had a file here, would it still get? Let's say this got removed or yeah. Okay, cool. Amazing. Alright, interesting. Let's also go back to the readme. Can also clean generated files sh sig run prebuild -- clean, and let's go. Nice. Amazing. So yeah, I wonder if I can actually generate, for example, that C imports.h directly in the file here instead of having to pass it. So exec, max out a bit, argv, allocator. Doesn't seem like there's anything there. I don't think we can do that though. Like basically piping a file into it. I do not think that's possible. Yep. Doesn't seem like. Oh, setup child IO. What's that? Well, hold on a second. If I go to what is it called even? Documentation? No, not this one. This one. Okay, cool. Let's see pipe. Create pipe. That doesn't seem so good. Let's see child process for now. ID, thread handle, cd out, term. Ooh, cdin behavior. Pipe. Well, there's a pipe field right there. Interestingly. But honestly, anyway, I think this is fine for now. So yeah, pretty much that's it, I guess, for today's video. I do not know if tomorrow I'm going to be streaming again. Maybe after tomorrow, possibly. I'm not sure about tomorrow. We'll see. Either way. So that was it for this live stream, and see you later, everyone. Oh, by the way, first of all, let me actually stage all the changes. And yeah. Third stream. Commit. Sync changes. Okay. Let's go. And let me make sure everything is fine. Amazing. Oh, I didn't remove the scripts though. We do not need these guys anymore. Move to trash. Move to trash. It's all in Zig now. Amazing. So let's just do that. Remove sh files. Commit. Sync changes. Okay. And yeah, pretty much. So we only have right now cimports.h, prebuild.zig, build.zig, and that's pretty much it. So yeah, that was it for this video, and see you later, everyone. Goodbye.